So now we have our basic geometry sorted out in the 3D model in Fusion 360. So now what we need to do is think about, first off, how can we refine this? So this could be things like smoothing it out. How might we iterate on this? We also need to be thinking about things like, let's double check all of the actual measurements, or at least the main ones, and make sure that we've got a model that fits our initial constraints and that's printable. So we're going to be looking at these topics in this video.
So when I think about the stages of CAD, first I'm thinking about basic geometry, and that's what we just finished. You look at this kind of matches our picture, but we're really not done. So what I like to think about next is smoothing out the parts, making sure that everything is printable, everything looks like it's going to come out nicely in the print. I want to avoid sharp edges. Um, Looking at this, I think I'm okay with. Am I okay with this? I think that I might prefer, actually, for this outer edge right here, to be chamfered. Because, this is 90 degrees. As we talked about before, 90-degree angles are kind of weak points, although there's no real stress on this part, so I'm not worried about that. But it does mean if I chamfer this now, let me just show, and I do that value smooth, let's just hit OK. I don't even have to hit OK. You can see from the preview. Let's zoom in. I now have a very thin wall right here, and that's because I didn't prepare for the chamfer in the initial measurements. So let's hit cancel, and let's see if we can fix this without breaking everything. So I'm going to go back to our very first sketch. And all I'm going to do, I think, is I'm going to add 2 smooths to this outer circle. So instead of 2 times smooth, it'll be 4 times smooth. And that's that. If we look at this now, if I just draw a little test line from here to here, now we're at 5, which is 3 wall width plus 2 smooth. So let's finish that sketch. And let's look at this. If we do measurement, maybe we can get it to show us, yeah, that is 5 millimeters exactly. So now, if I go and I do a chamfer out here, and I do smooth, I can now measure from this point to here, and we get our wall width again. So I still have my full wall width intact, and I have a little chamfer. And that's just so that if I'm trying to touch this with my, or hold this with my hand, I'm not holding kind of this sharp 90-degree edge. The other thing we had talked about before is this right here is a weak point. That's true. We can either fill it or we can chamfer it. In fact, it's the same situation with this edge. What was chamfer? But let's look at this as if it were a fillet. I can go back to shaded, and let me undo that and swap it out for a fillet. Okay. I think that'll work too. I don't think that there are going to be any issues printing that. I do think that since I set the value of smooth to 2, we'd probably want maybe a relatively small layer height. So just thinking ahead to the print part, the print phase. But I can also increase this smoothing by changing the smooth value to 3. We'll just do a little bit of undo redo, and you can actually see how this changed everything. We've increased the separation because I'm going to be adding smoothing, and I want to preserve that wall width, which I'm clearly doing. And now I've added to the smoothness. But I do want to make sure that that outer diameter is still acceptable, and we're back to 205. That's really about the limit. I'm okay with that, though. Additional smoothness is an acceptable trade-off for that to me. Now, I could also look at smoothing these off. I think that actually is not a bad idea. Now, would I be able to fit everything if I also added a smoothing there? That would add, I would have to account for it here on the left and the right, and again here on the left and the right, so I'd actually be up to a little bit too much. I can already tell you. If hypothetically I were to do that, I would be at 8 times smooth. And now we're at 217 millimeters outer diameter. That's too much. So what we could do is we could bring smooth back down to 2. Or, honestly, we could change the diameter of the handle base. 42 millimeters, that's a little bit less than 2 inches. Does it need to be that wide? Could it be 1 inch? I feel like that might be too narrow. But maybe a little bit less wouldn't be the worst thing. If I bring this down to 38 millimeters, let's see what that looks like. Okay, we just narrowed things out a little bit more. You can also see the effect on the top of the handle. And if I look at my outer diameter now, 201, so I still don't have quite that much leeway, but if I reduce the value of smooth down to 2, and now I go back to my original sketch, and now if I do 8 times smooth, what do I get to? 205. We've kind of gotten back to where we started with. I do think that this 2 millimeter smoothing should be sufficient just to make sure that things aren't sharp. Now that we've done that, we can add some fillets on the cup holders in the value of smooth. And I'm now wondering, did I miscompute? Because I want the distance from here to here is currently 3 millimeters. I think we're actually okay. So let me add a fillet here at the base, which is equal to smooth. Now, if you look at this, I'm not actually violating any minimum wall thickness concerns because this is kind of a downward smoothing action, whereas this is more of building up. So, or kind of building out. And we're adding that little bit of additional strength there. And actually, because of that, I think that it's totally fine. Minimum distance is 1. I can actually increase this specific value. I'm going to kind of cheat here and add smooth plus 1. And I think this will print just fine. And we will see this verified in the slicing stage. And like I said before, I think that we're okay at the top. One thing that would be nice is if the handle at the top was smoothed out. Let's see what that looks like. That can be a fillet too. I use the value of smooth up there. How does that look? I think that looks better. And again, we're avoiding those 90-degree angles. So, I actually just remembered, I forgot one very critical thing. Every time that I'm working with a functional print, I'm going to be inclined to add some tolerance to it. So if I want a part that let's say it's 30 millimeters, I want to fit it into a holder. I'm not going to make the holder 30 millimeters. I'm going to add a little bit of leeway to that. So if I go to parameters, this doesn't need to be a lot. You can, in practice, really go as low as maybe zero point 0.2 millimeters. That's a typical value for parts that fit into each other. But for large parts that fit into holders like this, I like to go for a little bit more, like at least a millimeter, maybe two. And actually, if you think about it, in this case, it's not a huge deal because the worst case is the holder is too tight and the cup will still fit into the holder. It just won't touch the bottom. That'll add more stress to the corners of the holder, which is not what I designed for. So I intend to avoid that, but it's actually not fatal. So I'm going to add a parameter and I'm going to call it tolerance. And I'm going to start with just 1 millimeter. And the way I'm going to add that is I'm imagining 1 extra millimeter on every side. So if you have a cylindrical holder, that means on the left I want 1 millimeter, on the right I want 1 millimeter, which means if I've got diameters all over the place, I need to add 2 to that diameter. And so I have this handy value over here, diameter of the holder. And it was computed, and I'm going to add 2 times tolerance. Okay. Let's do a little bit of undo, redo, and you can see that increase the size of the part. Now I am worried about the overall size. Let's measure it. 209.447. That's not great. I really don't want it to be that close to the edge of the print bed. I'd rather have a little bit of breathing room. So I'm going to actually bring down the diameter of the base again down to 36. We're just going to see how this goes. And that saved us and brought us down to 207. So I'm going to save it now. And one other critical thing that I forgot. Let's measure the height of this part. Top to bottom. Okay, so that is 228 millimeters. That's too high. Because if you remember, and this will be interesting, our upper limit for the print is actually 210. So we need to bring this down by at least 18, actually at least 19 millimeters. And again, I don't want it to be that close to the upper limit. The way that we change this is by changing the depth of the holder. I initially went for 1/3 of the height of the cup. And what is that? So 1/3 of the height of the cup is about 50, and I need to shave off 19. If I just quarter this, I'm gonna get about, what is a quarter of that? That's about 37.5. Not quite enough, but if I cut it in 5, so what have we gotten actually? Let's just measure it. Top to bottom, 208. Well, that is enough. That is enough. I'm a little bit less convinced that this is going to be high enough. So what I'm imagining now is let's revise. Instead of doing this, I'm not too comfortable with this. Instead of doing this approach, let's look at why I wanted some of the parameters that I initially did. This height, I imagined this to be equal to h. And I wanted that because I imagined loading in the cups basically strictly from right to left, if you imagine that, like this. Well, that's not really how it has to go. The top of the handle turned out to be a lot shorter than I initially imagined. I think that the cups are going to fit just fine if they have to be wedged a little bit. In fact, I think that when I added that clearance, so here's the clearance. We're going to take this down from 10 to 0. Let's see what that does. A little bit of undo redo, and we can see how it brings it down. And that means that what's remaining of this handle is just H, height of the cup. So it should fit exactly into this cup holder. So let's take a look at our dimensions again. So the outer diameter, 207, which is pretty high up there, kind of pushing it, is printable though. And how about the overall height? So from top to bottom, 218. So that's not printable. We have to bring it down further, at least 8 millimeters. So let's see what we can do. Now let's think about the parameters that we have again. So one thing I'm thinking is, we have this depth of the holder. Now in the sketching and concept phase, I kind of intuited that a third of the height of the cup might be a good value to retain the cup. But that was just a guess. And I'm thinking that especially because we're designing this so precisely, we can actually dial this down a little bit. And this should actually help us reduce both the height, because we're reducing the depth of the holders, and it's also going to help reduce the diameter, which might let us tweak some other things. So let's bring this down from 1/3 to 1/4 and see what it looks like. Let me do some undos so you can see. So it's brought down both the height and the diameter handily. Let's see exactly where. So the diameter is now 201.985. That's good. That's some more breathing room. And the overall height of the part, 206. That is printable. Perfect. So now, like I mentioned, we reduced the diameter by doing this. And I'm now thinking, how about that smooth parameter? We had reduced this from 3 to 2 earlier in an effort to save diameter because we were kind of at the limit. What happens if I increase this to 3 again? You can see that all those fillets, all that rounding off gets a little bit more intense. And it looks like we have maybe some funny business going on at the base of the handle. There are these new kind of sections appearing, and oh, I see. So before, when we made that rounding off, we had added in a little hack. We had added a millimeter to that, but that was a mistake. We really didn't need to do that. And if we remove that, now these fillets are nice and flush with each other. And what is our overall diameter now? 209. That's higher than I expected. So looking at this part, this actually looks... I want to double check a measurement here. So I want to verify our wall width, because this looks kind of large to me. So if you look at this, the distance from this... the edge of this fillet right here, this rounding off, to the edge of this one is 6. But here, we should only really have 3, actually. That should be wall width right there. So I think that what might have happened is in our sketch, earlier, if we look at the computation for the outer diameter, we had upped that from 4 smooth to 8 smooth. I think that this is actually 6 smooth, and the reason is we need that extra... We need that extra wall width on the left. We need it on the right. But actually, I don't think we need it in the center because we're happy for those 2 fillets to be flush with each other. So let's take a look now. Minimum distance 3 millimeters. That looks perfect to me. And now what's the result as far as the outer diameter? 203.985. That looks good to me, and let's just double check the overall height. 206.213. Also looks great to me. That's printable. Our fillets are nice. They are flush with each other here. And just a note, like the reason why I'm okay with these fillets being flush with each other, if you look at them closer, again, this fillet, is kind of building out, whereas this one is kind of building in. If you think about the wall widths involved, by having these right next to each other, there's no minimum wall width violation. So we don't introduce any thin walls here. So we should be okay. Okay. So at this point, I think that we can export this and move on to the slicing phase. So let's right click our component cup holder, save as mesh. I prefer the 3MF format, which includes some extra metadata like the units. And I think it's superior to STL. And then high refinement, and then I'll save this and we can move on to slicing where we prepare the mesh to be printed.
So now we're done with all the refinement and iteration. And we, as you saw, we learned a lot in this process. We made a lot of improvements. We corrected a lot of faulty assumptions or miscalculations and came up with a part that we should be a lot more confident is going to be a good print, a good mechanical part. So the next step is to actually do the slicing process, which is where we convert the mesh, the 3D mesh that we produced here, into a set of instructions for the 3D printer to use to produce our project and turn our imagination into reality. So look out for that in the next video.